Okay guys, here's your video and notes for 3.2. We're going to still be talking about alternate interior, alternate exterior, those kinds of angles we learned about last night. Only now we're going to be talking about their measures if the lines are parallel. So before, the lines that weren't the transversals, we didn't care if they were parallel or not. They could be or they didn't have to be. But today we're going to be more specific. When they are parallel and they're cut by a transversal, then all those angle pairs we talked about are either going to be congruent or they're going to be supplementary. And we'll learn which ones are which as we go throughout the notes. Okay, so the first thing on your vocabulary grid, the first one you see is corresponding angle postulate, and that says if parallel lines are cut by a transversal, then corresponding angles are congruent. Remember, corresponding are the ones that are in the same location but in a different intersection. So this would be top right, this would be top right, so those would be corresponding. And now we know from the postulate that those are going to be congruent to one another. Okay, so here we're going to find the angle measure and then justify. And by justify, I mean which postulate did you use to get there. You don't have to do like, I use this postulate and then addition and then simplify, and then you just have to tell me the main postulate that got you there. Okay, so find the measure of ECF. So we're looking for this one right here. So if we look across, we can see that this one is in the bottom right, and so is the 70 degree in the bottom right. So we don't even have to do any math in this one. We can see ESC is 70 degrees by the corresponding angles postulate. And that's what I mean by justify, that postulate right there. Easy enough? Okay. So the measure of DCE, so I'm looking at this one now, and he is in the top right. So if I look over to the other intersection in the top right is this 4x plus 22. I know corresponding angles are congruent, meaning their measures are equal. So I can say 4x plus 22 is equal to 5x, and I can still justify with the corresponding angles postulate. From here, I just have to solve. So I'm going to subtract 4x. So I'm left with x is equal to 22, but is x equals 22 my final answer? No, because I'm asked to find DCE, so I need to plug that back in instead. Hold on one second. So I'm going to go and plug that back in, and you really, since these are the same measures, you can plug them into either one. So choose the easier one, which in this case does happen to be DCE. So I'm going to do 5 times 22 and get that that is a measure of 110 degrees, and that's my final answer. So you need the 110 as your final answer, and you need the corresponding angles postulate. So that would be like half and half credit, so don't forget that. Okay, alternate interior angles proof. So you have the alternate interior angles theorem in your vocabulary grid, but we're going to prove why it's true. And then from here on out, every time you see alternate interior angles, you can just go straight to the fact that they're congruent. You don't have to take this step. But for now, I'm going to show you why that's true. So we're given that L is parallel to M, and I want to prove that angle 2 is congruent to angle 3. Okay, so two things that I know from looking at this picture over here. One of them I just learned just now. I know that angle 1 is congruent to angle 3 because of that corresponding angles postulate. So since this one is top right and this one is top right, I know that those are congruent to one another like I just did. Then from chapter 1, I know that angle 1 is congruent to angle 2 because those are vertical angles, so that would be the vertical angles theorem. If angles are vertical, then they have to be congruent. Okay. Then, if you can see, both 2 and 3 are both congruent to angle 1, so that means that they're congruent to one another. Now, if this were equal sign, you could choose if you wanted to use substitution or transitive, but we can't do substitution over congruency, so my only choice is to use the transitive property of congruence. And that is one of the few mistakes that a bunch of people made on the test last week was that you tried to call this substitution. Substitution only works with equality. So if you have that A to B and B to C thing going on with congruency, you have to use transitive property. You're not allowed to use substitution. So very easy, four quick steps to see that now anytime I want to, when I see two angles that are alternate interior, I don't have to go through this mess. I can just right away say, okay, 2 and 3 are congruent because of alternate interior angles theorem. Okay, so we'll be using that one a lot as well. All right. Okay, to your vocabulary grid, we're not going to prove the other two, but we could if we wanted to. We can see that alternate exterior angles are also congruent and that same side interior angles are supplementary. So basically all of them are congruent except for same side interior, and those are going to be supplementary. So now we know all of them that we need to work with. Okay, so EDF, let's mark that. EDF is X right here. The only other angle we're given is ABC. These two are alternate exterior, and we just learned that alternate exterior angles are congruent. So we know that EDF is 125 degrees by the alternate exterior angles theorem. Okay, we need to put that because the problem says to justify. Okay, scooting down to the next problem where we have a little algebra. Okay. EDG, and this is E down here. I don't want to uncover this because I have the answer to part C. So I want to find EDG, which is X minus 30. Now I could use this, but that's not going to get me very far because I have just all variables. I could use 2X minus 135 because these two are corresponding angles. And I learned on the last page that corresponding angles were congruent. So I could use that and use corresponding angles postulate and find out what X is for sure. But even easier than that would be to use the guy without any algebra to try to use the 75 degrees. So that's the way I'm going to go just because it's easier. If you wanted to do corresponding, you could go right for it. But these two, the one I want and the one without any algebra, are alternate exterior. So I already know that alternate exterior angles are congruent, so I can say X minus 30 has to be equal to 75 by the alternate exterior angles theorem. Then it's not as much algebra as if I had done corresponding. All I have to do is add 30 to both sides, so X is equal to 105 degrees. Now be careful, I don't want X, I want this angle EDG, which is X minus 30. So if I just take off 30, then I'm left with 75 degrees. So my final answer is 75 degrees by the alternate exterior angles theorem. If you had done corresponding and plugged it, you would have still got X equals 105, and you would have still plugged it back in and got 75 degrees. It just would have been a little bit more algebra right here. So really you have kind of your choice. Okay, pause right here and try to do C. Again, there are several ways to do C, so choose your favorite. Okay, the easiest way to do C would be to figure out that you already knew how much X was from the previous problem. But since we're trying to work on our skills here, not just find the answer the fastest, I went ahead and showed you a couple of different things here. So one way that could jump to mind that we haven't used yet is X and this 2X minus 35 are same side interior angles, and same side interior angles are the only ones that are supplementary. So I set up that equation here. This angle plus this angle equals 180. Simplified, 3X minus 135 is equal to 180. Move the 135, 3X is equal to 315. And got my X is equal to 105. Now, of course, I already knew it was 105 from this side, but I'm just showing you a different way. Okay. Another way that you could do this is without using the new material at all, which is using what we learned in Chapter 1, and knowing that this angle BDG, this X, and GDE are a linear pair. So I could do, if this one, that they have to add up to 180, so if I already knew 75, 180 minus 75 is equal to X by the linear pair theorem, and then I could do x is equal to 105 here. So many choices. Getting your answer from a previous problem that you worked hard to get, same side interior angles theorem, or linear pair theorem. Either one of those will get you to the same 105-degree answer. Okay, last one is a little more complicated. Here we have 3 lines that are all parallel to one another. So I'm only going to use 2 at a time, but I can use any 2 that help me get this problem. Okay, I need to find x and y. So when I look to my algebra, I notice that this angle has an x and a y mixed in, as does this one. So this is going to have to be a system of equations. There's not going to be a one-shot deal. Remember systems of equations from Algebra 1, where if you have 2 variables, you need 2 equations and solve them simultaneously. Okay, so I'm going to start with this one, this 5x plus 4y, and I'm looking to see who he is related to. So if I kind of ignore this middle line right here, I can see that 5x plus 4y and 55 are alternate interior angles. Okay, they're interior of these outside 2. This one's on top, this one's on the bottom of the transversal, so alternate interior. We already know that alternate interior angles are congruent. Whoops, how about 55? So this is one valid equation for this one. Then moving on to the other one, 5x plus 5y. If I look at this 60 degrees right here, this one is in the bottom left, as is, I can ignore this third line over here. These are corresponding, and I know by the corresponding angles postulate that those are congruent, so I can set that equal to 60 degrees. Now, if you need to pause or rewind that to watch how I got those again, feel free. Anytime you add an extra parallel line and an extra transversal, things get a little more confusing, so you have to be very careful, mark them carefully, that kind of thing. Okay, remember from Algebra 1 that there's several ways that you can solve a system of equations. This one looks like it'd be best to use the elimination method. Remember, with elimination, you're looking to find a variable that has the same coefficient but an opposite sign. That way, when you add the 2 equations together, one of the variables cancels out. So it doesn't matter which one I change. I'm going to change the top one just to keep it all positive. So I'm going to change this to a negative 5x. That way you can see positive 5x and negative 5x will cancel out. But if I change it here, I've got to change it all the way through the problem. So I'm going to change this to negative 4y and this to negative 55. Okay, if you don't remember systems of equations, you can come into tutorials and I'll give you a quick recap of it. Okay, the point of being that these 2 would cancel out, and then I would have 5y minus 4y, and that would just be a y left. 60 minus 55 would just be 5. So I'm halfway done with the problem because I know that y is equal to 5. Now what I can do is go and plug that back into either equation to solve from there. I always choose to plug it into the one that I didn't mess with, just in case something went wrong. So I'm going to plug it into the bottom one. 5x plus 5, now I know 5 is y, so I can substitute that back in, is 60. 5x plus 25 is equal to 60. Move the 25. 5x is equal to 35. X is equal to 7. I guess it wouldn't be degrees. It would just be 5 and 7. Okay, so that problem was a little challenging. We'll work with some more of those in class tomorrow, since I know that was the harder one. But if you can get out of there, these 2 are alternate interior, so they're congruent. These 2 are corresponding, so they're congruent. And then get one variable to cancel out, substitute back into the other variable. Okay, see you tomorrow.